Lesson 74 is about scientific notation, and scientific notation is basically just a really simplified way or easier way of working with really huge numbers. For example, if you were an engineer and you had this number that you had to keep writing down over and over, that would really be a pain to have to keep writing it out so large like that. So that's where scientific notation comes in handy. And what you do is you just keep moving over the decimal point. You know, originally it's right here. We haven't drawn it on there, but that's where it started. And so we move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. And so each time we move over a decimal place, we move over a multiple of 10. Not really a multiple of 10, but a power of 10. So we move over once, and that's equal to 10 to the 1. We move over twice, that's equal to 10 to the 2, and so on. We moved over 11 places, so we would put the decimal point right there between the 7 and the 3, and we would say 7.34 times 10 to the 11th. That's what scientific notation is. You just take the whole number part, or actually I guess you could just say the counting number part of a large real number, move the decimal point just before the first non-zero number like that, and then you say times, like in this example, times 10 to the 11th power. Every time we move the decimal point to the left, we increase that power one time. The same idea applies to really, really small numbers too. Again, you wouldn't want to have to write out that number over and over if you had to use it a lot. So you can use scientific notation, and in this case we'd move the decimal place to the right. 1, 2, 3, 4, 5, 6, 7, 8 places. We move it to the right of the first non-zero number. So now we would have 9.3, and it's basically like dividing 9.3 by 10 to the 8th power. 9.3 divided by 10 to the 8th would get us back to that original number, but that's not how we write the scientific notation. We just move it as a factor, move it up as a factor, and so therefore we change the sign. 9.3 times 10 to the minus 8 is how we would say that. So as a general rule, what you can think of is move to the left. If you move that decimal place to the left, you add positive values to the exponent of 10. If you move the decimal place to the right, you add negative values to the exponent of 10. Let's go ahead and do some practice problems. Write that practice problem A using scientific notation. So what you want to do, you just think, well, I need to move the decimal place in front of that first non-zero number. And so I go 1, 2, 3, like that. And so I moved it to the left 3, so that means I'll be adding positive 3 to the exponent of 10. And so I say 5.53 times 10 to the third. 10 to the third is 1,000, so basically we're saying 5.53 times 1,000. I mean, these are equal quantities. It just looks different. 5.53 times 10 to the third looks different than 5530, but of course they're the same number. Look at practice problem B. 5,530 times 10 to the 8th. I want you to write that in scientific notation. Well, you might be thinking to yourself, well, it already is in scientific notation. What do I have to do to it? Well, it's not in standard form for scientific notation. Standard form means the decimal point is to the right of the first non-zero number. And so that means you need to move it over 1, 2, 3. And it needs to go right there. So if we move it over 3, we just add 3 to the existing power of 10. And so that would be 5.53 times 10 to the 11th. So that's how you would write that. Let's do one more problem. In this one, again, it's not in standard form. We need the decimal point in front of the first non-zero number. And so we need to move it to the right 1, 2. So this time we move the decimal point to the right. Remember what you do on those? You add negative numbers to the exponent. So that would be a -2 that we add to 10 to the 4th. And so we would say 5.53 times 10 to the 4 minus 2, or just 2. So that's the standard scientific notation format. So scientific notation format, it's just a way of getting rid of all of the zeros in a really, really large or really, really small number. Combining those as a power of 10 that you multiply by the non-zero digits. You still have the same number that you're working with, it's just in a different format. Okay, well that's all for lesson 74.